Hi everyone, this is 11.6. In this lesson, we're going to learn how to find the volume of cylinders and different types of prisms. But we're going to start with two very important vocabulary words for this lesson here. Our first word is polyhedron. A polyhedron is a solid, and a solid is a three-dimensional figure. So a polyhedron is a solid that is made up of polygonal sides. For example, all these solids here are made up of polygonal sides. Look at this first one here, a triangular prism. This side, this side, this side, the bottom and the back, they're all polygons. Each side is a polygon in this figure here. So this solid is a polyhedron because it's made up of polygonal faces, or you could say polygonal sides. It's called a triangular prism because its base, that's why they labeled this B, its base, and a prism has two bases. Here's one here, and the other one is in the back. So prism has two bases. The base gives the prism its name. So if the base is a triangle, then it's a triangular prism. If the base is a square, then it's a square prism. If the base is a trapezoid, then it's a trapezoidal prism. Okay? All right, so here's a rectangular prism because this base right here is rectangular. Here's the first base, and the other one is in the back. This is called a pentagonal prism because the base of this solid here is a pentagon. Here's your first base, and the second one's at the bottom. Here's another example of a triangular prism, hexagonal prism, because the base is made up of 6 sides, and this is an octagonal prism because the base is made up of 8 sides. All these solids are called polyhedrons, again, because they're made up of polygonal faces. In contrast, a cylinder is not a polyhedron because it is not made up of polygonal sides. Let's look at the sketch of a cylinder. It is not made up of polygonal faces. So a cylinder, because it has a curved circular shape, because of the curves, it is not a polyhedron. All right, so this brings us to our first theorem, volume of a prism. The volume of a prism is found by taking the base times the height. And this is considered the base. B represents the base, and when we say base, we mean the area of the base times the height. So that's how we find the volume of a rectangular prism. Let's do that. Here's our first example. Let me go back and say, when we're talking about a rectangular prism, this side is the length, this side is the width, and this side is the height. All right, so let's find the volume of this rectangular prism. This side is 6 yards, this side is 8 yards, and this side is 15 yards. So it's the base, which is this part right here, 6 times 8. So it's the base times the height. Well, the base is 6 times 8, so that's what we have here, 6 times 8 times the height, which is 15. So 6 times 8 is 48 times 15. That's 720 yards cubed. Okay, let's look at the next one. So again, the volume is the base times the height, and this is the base right here. That's 5 times 4. So 5 times 4 times the height, which is 3. So that's 5 times 4, that's 20 times 3, that's 60 inches cubed. All right, here we have been given the volume. We need to find the sides. Each side is the same length. So this is a cube. So this would be x cubed because each side is x. X times x times x is the volume. But we have been given that the volume is 1,000, so I can replace v with 1,000 equals x cubed. I can now take the square root, now I can take the cube root of each side so that I can find x. So x is, the cube root of 1,000 is 10 because 10 times 10 times 10 is 1,000. So let's say you are trying to find the cube root of a difficult number, for example, 58. You want the cube root of 58, and you don't know how to do that in your calculator. So I'm going to show you. So you're going to take the cube root of both sides. So then you're going to end up with x equals, here's what you do on your calculator. First thing you do is type 58. Then go to the key labeled second, hit that. And then the third thing you do is go to the key labeled 0. Okay, what you're trying to do is really access the lower function labeled as cube root. So you're going to hit 58, go to second, go to 0, and then it's going to give you your answer. I'm going to do that right now. And it is approximately 3.8. 3.9. So that's how you would do that on your calculator. All right, so the next thing we're going to look at is how to find the volume of a cylinder. And this theorem gives us the volume of a cylinder. The volume of a cylinder is base times height, where base represents the circular base of the cylinder. It represents the area. So base represents the area of the circle. Times the height. So that's how you find the volume of a cylinder. You take the area of the circle, which is called the base, times the height. All right, let's work some examples. Oh, by the way, this is called a right cylinder. This is called an oblique cylinder because of the way it's slanted. It's not sitting upright. This one is. This one is perpendicular to the base. This one is not. All right, so let's look at this example right here and find the volume of a cylinder. All right, so it's base times height. Well, the base is the circle. We want the area of the circle with a radius of 3. So we will take pi radius squared for the area of the circle. This gives us pi 3 squared, and then times the height, which is 6. And we get the volume of this cylinder here, which is 54 pi. And when we multiply that out, 54 times pi, we get a decimal answer of approximately 169.6. And this is meters cubed. All right, let's try an example. All right, let's find the volume of this cylinder. So it's the area of the circle, which is pi r squared times the height. Pi is just pi, the radius is 9, and we'll square that, and the height is 6. So let's multiply that out. That's 81 times 6, which will give us 486 pi. Let's multiply that out and see what that is approximately. Times pi. 1,526.8 feet cubed. All right, in this problem here, we have been given the volume. They want us to find the height. Okay, so we've been given everything except the height. So we're going to use the formula again, the same way. Volume equals base times height. We're going to replace V with the volume, and the volume is 314. It's given right here. So replace V with 314. And the formula, since we're talking about a cylinder, is going to be the area of the circle, pi. The radius of the cylinder here, the diameter is 10, so the radius is 5. So it's going to be pi times 5 squared times the height. But I don't have the height, so we'll just keep that as h. 5 squared is pi, so I'll have 25 pi. H equals 314. So if you divide both sides by 25 pi, you'll end up with the height, which is 4. So let's try some examples. We've been given the volume. The volume is 176 centimeters. So let me write the formula. Volume equals pi r squared times h. I've been given the volume. That's 176. Pi is just pi. This, I've been given the diameter. I need the radius. It's half of the diameter, so this has to be 4 if the diameter is 8. So we'll have 4 squared times the height. We don't have the height, so we'll just keep that as h. So 176, 4 squared, that's 16, so I'll have 16 pi h. Let's divide both sides by 16 pi. So what I'm going to do is take 16 times pi and divide that out. So I'll have 176 over 50.3, rounding to the nearest tenth. And then I'll divide that out. 176 divided by 50.3, that'll give me h. So h is approximately 3.5, the height. All right, here we're finding the diameter. So x is the diameter. So volume equals pi r squared times h. I've been given the volume. It's 128 pi. Pi is just pi. I don't have the radius. So that's just going to be r squared. I do have the height, which is 8. Okay, so I'll have 128 pi equals 8 pi r squared. I will divide both sides by 8 pi. So I have radius squared. The pi's cancel out. 128 divided by 8 is 16. And the radius, take the square root of both sides. So the radius is 4. Well, if the radius is 4, then that means the diameter, and that's what we're trying to find, is 8. So x equals 8. All right, so now let's try finding the volume of a triangular prism. And the reason it's called a triangular prism, because the base of this prism is a triangle. So here's one base, and the other one is down here. Again, the prism gets its name from its base. We have 2 triangular bases, and the distance between these triangular bases is the height. So 2 is the height. This is h equals 2. To find the volume of a triangular prism, it's also found this way. Volume equals base times height, where base is the area of the triangle. Okay, so I'm going to do that over here. The area of the triangle, that's going to be 1/2. The height of the triangle is 4 and the base is 3. So 1/2 3 times 4. So that's the base, that's B, times the height, and the height is 2. So the volume equals, well, 3 times 4 is 12, half of that is 6, so we'll have 6 times 2, so that's 12. So the volume of this triangular prism is 12 centimeters cubed. All right, let's look at some more examples. So the volume of this triangular prism is the base, which is a triangle, so the area of the base, which will be 1/2 5 times 12, all that, times the height, which is the distance between the front base and the back base. You see we have the front base, back base, the distance between them is the height, so that's 9. And now we'll just multiply everything out. So half of 12 is 6 times 5, that's 30, times 9, that's 270 meters cubed. All right, let's look at the next example. So the volume, again, it's a triangular base, so it's going to be 1/2 times the base 7 times the height 10 of the triangular base, all that times the distance, which is the height, the distance between our upper triangular base and our bottom triangular base. And that distance is right here, 5. So you got to make sure you find the correct height. All right, half of 10 is 5 times 7, that's 35 times 5. So that's 175. Volume is 175 inches cubed. So this was 5, this was 5 inches, this was 10 inches, and this was 7 inches. All right, I'm going to skip over to number 4. We need to find this side of this triangular prism. So volume equals, again, it's base times height. We have the volume, 45, equals the base. Well, the base is 5 times 9, 1/2, 5 times 9, and all that times the height, and x is basically the height. This is the distance between this base, this triangular base, and the back triangular base. So that would just be x. All right, so let's multiply this out. This is going to be 22.5x. Divide both sides by 22.5. So x is 2. So the height is 2. So now we're going to find the volume of a right trapezoidal prism. Okay, the way we find the volume of a trapezoidal prism is the same way we find the volume of any prism. The volume equals base times height. The base, in this case here, I'm going to write that out. The base is a trapezoid. So you're going to take the area of the trapezoid times the height. I'll just put h for height. That's how you find the volume of a trapezoid. You need to know the formula for finding the area of the trapezoid, and that would be 1/2 h base 1 plus base 2. So the volume equals the base. Let's find that. So that's 1/2 height prism, which is 1.8. Base 1 plus base 2. Base 1 is 1.2 plus base 2, which is 2.3. Okay, all that this is just the area of the trapezoid times the height, the distance between this trapezoidal base and the one in the back. So that distance is 2, or that height is 2. So now we just do the math from here. All right, let me go ahead and add what's inside the parentheses. So that's 3.5. And now I'm going to multiply all that out. So 2 times 3.5 times 1.8 equals, divide that by 2 since I'm taking half. So the volume for this one is 6.3 centimeters cubed. This one is the same one we just did above. So we'll just go on to see. All right, so volume equals the base, which is this trapezoid. So 1/2. The height of this trapezoid, it's this distance right here, from top to bottom, the perpendicular height. And are we given that amount? Yes, that's 4.3. We're given that amount right here, 4.3. Okay, we want the sum of base 1 and base 2. This is 3 and this is 8. So it's 3 plus 8. So this is all just the area of the of the trapezoidal base. Now I have to multiply that. Now I have to multiply that by the height, the distance between these two bases, which is this distance right here, which is given right here, 4. So now I have to just simplify what I have. 1/2, 4.3 times 11 times 4. So I'm going to multiply everything out. 4 times 11 times 4.3 equals, and I'm going to divide by 2. So the volume is equal to 94.6 meters cubed. All right, so this brings us to Cavallari's principle, which I do cover in another video in part 2, but I'll go over it quickly. Here's what the principle says. Cavallari's principle states that if 2 or more solids have the same height and the same cross-sectional area at every level, then they have the same volume. All right, so we have these two rectangular prisms. This one is a right rectangular prism. This one here is oblique. And I have another example here. I have 2 rectangular prisms here and a cylinder. So what this principle says, if you cut out a cross section, and they've highlighted this in purple, so B represents a cross section. If you cut this piece out and you cut this piece out, and these are being cut from the same height of each one of these solids, and we find that they all have the same area. And if we did that at every level of these 3 solids, and these solids have the same height, then that means these solids have the same volume. So I'll say that again. If we slice these solids in the same exact way at every single level, and every cross section has the same area, then that means these three solids have the same volume. They do have to have the same height. So if they have the same height and they have the same cross-sectional area at each level that we slice through these solids, then these solids have the same volume. That's what this principle says. All right, so here we are looking at an oblique cylinder, and the way you find the volume of an oblique cylinder is exactly the way you find the volume of a right cylinder. Okay, the first one has been done for us right here. So the height here is outside 7 centimeters, and the radius is 4. They did all the work here. And so when you find the volume of this cylinder, you will get 351.86. All right, so let's work some more examples. Let's find the volume of this oblique rectangular prism. The volume is going to be base or length with height, which is the same thing as base times height, where the base is the base of the rectangular prism. So that's 4 times 7, which is 28 times 6. So 28 times 6, the volume is 168 inches cubed. All right, let's find the volume of this oblique cylinder. Volume is pi r squared times h. Pi is just pi, and the radius is 8. We'll square that. And the height is outside here. It's 14. So we'll multiply all that out. That's 64 times 14 times pi. And the volume will be approximately 2,814.9, approximately. And that's feet cubed. So here, for this example, we're supposed to find the volume, but we have not been given the height. Okay, the height is missing, but we have been given enough information to find the height. We can use trig. So this side is the same length as this side. If this is 18, this is 18. So we can say the sine of 60 degrees, sine of this angle right here is height over hypotenuse. So that would be h over 118, over 18, multiply both sides by 18, and we're going to get the height. So the height is 18 times sine of 60 degrees. So let's see what that is. 60 degrees sine times 18, that's approximately, so the height is approximately 15.6. We did not find the volume yet. We just found the height. Now we can find the volume. So the volume is the area of the base, pi. The radius is 6, because the diameter is 12, and the height is 15.6. We just multiply all that out. Times 36 times pi. So the volume is 1,763 approximately. That's approximately meters cubed. All right, so we want the volume of this oblique triangular prism. We will find it the same way we find a right triangular prism, base times height. So the volume, well, since the base is a triangle, so it's going to be 1/2, we're finding the area of the triangle, 1/2 9 times 5, so that's the area of the triangle, times the height. Well, the height is given outside here. It's the distance between this triangular base and this triangular base. So that's 8. And now we'll just multiply everything out. 9 times 5 is 45. Half of that is 22 and a half. 22.5 times 8. That's 180. And that will be meters cubed. All right, so let's find the volume of these different types of prisms. So this is a pentagonal prism because the base is a pentagon. So it's called the pentagonal prism. They already found the area of the base for us. It's given as 43. So B is 43 millimeters squared. So we don't have to find B. It's given. So the volume is just base times height. The area of the base, which is given, 43, times the height. And the height is the distance between the front base and the bottom base, or the back base. So that's 43 times 15. So the volume is 43 times 15. That's 645 millimeters cubed, since this is volume. All right, this is a hexagonal prism. 1, 2, 3, 4, 5, 6. So it's a hexagonal prism. So volume is, again, base times height. They already gave us the base. The area of the base is 166. That's given. And the height, the distance between this base and this base, so that's 20. So the volume is 166 times 20. So it's 3,320 feet cubed. All right, so to find the volume of this solid here, well, a part of it's been cut out. We can look at it as if nothing was cut out, the whole thing. Which is 3, side is 1, and this side is 3. So the whole thing is 3 times 1 is 3. Yeah, 3. 3 times 1 is 3 times 3 is 9. So it's 9 minus this part that's cut out. We need the dimensions of this part that's cut out. Well, this whole distance is 3. This distance is 1, so that means this distance is 2. Well, this whole distance is 3. This whole distance is 2. That means 1. This is 1. 1 has been cut out. And this distance here is also 1. So we have to cut out minus this smaller rectangular prism. 2, 1, and 1. So 2 times 1 times 1 is just 2. So 9 minus 2, that's going to be 7 units cubed. So that's how you find the volume of a solid where some part of it is missing. You just subtract out the part that's missing. This is a composite solid. It's made up of a half a cylinder and a rectangular prism. So you find the volume of the rectangular prism, which is 4 times 4 times 4. And then you add that to the volume of the cylinder. Let's find the volume of the cylinder. It's pi. The radius, well, this is the diameter, so the radius has to be 2 squared plus, no, I'm sorry, times the height. All right, so the height of the cylinder is this distance right here, from this circular base to the back. So that's 4. So this volume here, that's 4, that's 16 pi. Let's see, what is 16 pi? 16 times pi, that's 50.0 3, but this is a whole cylinder. We need only half of that. So let's take half of that, divide by 2, because we only need half. I only have half of a cylinder. So this is 64. So then the volume is 64, the rectangular prism, plus half the cylinder. Half the cylinder is 25.1. And then add them together. So the volume is 89.1 inches cubed. All right, last one. So we've been given the volume of this solid here. So the volume is 90. So I'll replace V with 90. And they want us to find each side. Each side is X. So we're going to take the cubic root of both sides. So you type 90, go to second, and then go to 0. So you're going to find that X is approximately 4.5. So each side is approximately 4.5. And if you take 4.5 and cube that, you should get 90. All right, and this concludes 11.6 on the volume of cylinders and prisms.